Okay, this is Brother Mike on the CapDump that I've been working on. You see the circuit, the CKT, the circuit, that's the dump circuit, right? And then you see the coils, you see the emitter and the collector and the 5-5 timer that controls the CapDump circuit, the Mosfets, and the little LED light flashing. Well, there is my alteration. I put these coils in the lines of the emitter and the collector. Okay, here they are. Let's get over here and take a look at them. They are, it's a bit noisy in here because I'm charging only a 12-volt battery, plus I'm running the inverter. But if you notice the colorful coils, for those of you who've seen my other videos, this is the CapDump down below. You'll see the blue caps. And then as we come up, I got a new meter, by the way. You can see it fluctuating there. I'm only charging from 30 to, there's a little bit of a shadow there. See if I can get this without a shadow for you. There's a shadow there. But anyways, it's charging 30 to 18 volts, and then here's the amp meter. See if you can see that, and that's hard to see. That's approximately 40 amps. I can get more. That's 100 and a 200 amp meter I switched out. Approximately 35. Oh, there goes the big fan on it. See you can see the sink fan clicks on because I have this little part right here, which is an air conditioner thermostat with a bulb on the heatsink. But these coils I wanted to show you. They just happen to be that color, so the two center ones are collector and the two outer ones, black and green, are emitter. And these give off a slight bit of heat. The Mosfets run not at 150 anymore, but more like 92. And these run at about 95, I think it was. Well, that depends on if the fan's running a little, but they're just a little bit warmer than the sink, like 2 degrees or something, if I remember right. In other words, they are giving off a little heat and protecting or arresting some of the arcs that destroy the junctions. And this is part of normal electronics where they're switching. They use coils to arrest these arcs so that it doesn't destroy your circuit in the long run, right? Okay, so that's all I wanted to say. And there's that same old silly circuit over there, that 5-5 timer just blinking away with the two controls on it. And of course, if I improve that, it'll help the heat issue. But I've got it solved. For those of you who don't want to build fancy circuits, and those fancy circuits are not present in the patents, by the way, like John Bedini's, it's not necessary. I mean, it would help, depending on how high the power level is, but selecting the right MOSFET and the right number of MOSFETs and then having these arrestor coils helps a great deal. And I can also go up to 50 amps. I can do up to 60 amp surges with this setup now. Right now it's running 3540 because I'm running only a 12 volt, but I had this today. I had this all the way up here and dumping back down like that, and this was running 50 amp pulses today with two batteries with 24 volt system. So there they are. Oh, and there goes the heat sink. It just turned off, you know, the control on it. I wanted to show you the chalkboard with the coils on it, the in and out on each side. There's six on that side and there's 6 on this side, so I have two coils, you know, for each side, and you can see the collector, the red and the white one collector, they go to the battery charge terminal. It goes out to the amp meter where you get to see the pulses. Now I can adjust this circuit around, and I'll show you some adjustments. I'm going to reach down here and I'm going to turn this timing one and this one here, and I want you to watch what happens. Now right now that's zero, that's like 18 volts to 30, which you're seeing a shadow is what you're seeing, and the red line right next to it. Let's say I extend that, I can get that up higher. See? I can make that go up higher and down lower. I'm running that up to darn near 60 volts. Now here's the amp fluctuations on it. Still about the same. And I can adjust it further so it cuts it down. And there was some other things I wanted to show you too. The main thing I wanted to show you, not so much the surging there, but now we're getting a higher surge. Well, I was going to show you the cords, the lines coming in and out. I don't know if you can see them, but as the pulses come, you can feel all the lines shake, especially with 24 volts hooked up and running the voltage up higher. And I was hoping to show you that, but tonight I'm just charging a well, you might be able to see it over there. You probably, no, you can't see the lines move because I'm running low voltage, but I'll tell you what, when these click in the day and I'm running a 50 or 60 amp pulse, the whole wall shakes, the line shakes, and that's the wire you see here running from the switch. That's the stuff that's on your telephone pole, from pole to pole, that thick wire. And it's really heavy duty, high density polyethylene around coating. It's real indestructible, and it's like a 60 or an 80 amp capable cable, and that whole thing, all those lines jiggle when I'm charging it with 24 volts. But you can see I got the amp pulse up to 50 now, and then there goes the heat sink again. It's turning on, and you need to also see the other meter. I don't know if you can see it down there. That's too much. See, that's surging up to, I don't usually do that. I'm not usually running 12 volts, so I'm going to adjust this so that it doesn't fluctuate so badly. And the way I do that is I go over here to my resistor bank, and I make more resistance so that there's not so much incoming current when it dumps. So that is an issue. And I'm doing that right now. So now I've got a full 12 ohms of resistance in the line, and you'll see the difference. I'll get the pulses back up there for you. Let's get those pulses up there. Okay, let's get them up to right now they're at 35. Let's get them up to 50 there. See, they go to 60 on this, but we'll just hit them with, and there's no problem with this circuit either as far as handling it. The heat sink don't even turn on. See, these coils arrest a lot of that that arcing that the junctions were suffering. Those coils are great for arresting, but it doesn't take away from the charging at all. Now watch the difference. I'm getting a 50 amp pulse, right? Now watch the difference down here on the supply. Let's see if you can see that. See that? It's only fluctuating a few points, maybe 5 or 6 points. It's down to 2 or 3 and up to about 9 amps. You see that? Where before it's shooting over to 20. So you have to change your input resistance depending on what you're doing. I have 3 settings on my resistor over here. My resistor box. I burnt out my fan today goofing around, but that's a dryer coil. It can handle any heat I put on it, and this is just a temporary means to an end. But I have this gator clamp, I have this gator clamp, I have these gator clamps over here, and these terminals, 2 terminals here, and I can switch from 12 to 6 to 3 ohms of resistance depending on if I'm going slow. Now if I speed this up, I can speed this up a little for you. You'll see the pulses drop in half. See it drop in half? There, it's charging up there. And then the same thing down here, but the fluctuations are way smaller. See how little the fluctuations are on the input? It barely moves. So you're running about maybe 7-8 amps there. That's a 10 there. From 0 to 10. And then 20 and then 30. That's a 30 amp gauge. So you see how adjusting the pulses affects. That's a 25 amp pulse, and we're running up to about 40 plus volts on a 12 volt battery. We're just beating that big old battery in the basement hard. There, that's how you focus that in better. Maybe you can see that better, huh? That's a little too much. And I like to adjust it down somewhere in here around 30, 35 is fine. And you're still getting the same 25 amp pulses no matter what. You just want to adjust your voltage and watch your circuit, you know, and someday maybe make it automatic once I figure out what's proper or what I'm looking for. Helps first. Well, there they are, and the main thing is I wanted you to, you can't feel it, but it's, I mean, I'm feeling it. You can't feel it through the video, but they're clicking. I mean, they're you can feel it thumping, especially with 24 volt system. When I'm running up 80 volts and it thumps out 50 amps or 60, wow. And my Mosfet stays so nice and cool, and these run up a little bit. They're 2 degrees higher than the energy running through the system, so you know they're working. You can feel and sense the difference. They're 2, maybe 3 degrees hotter, which is only sometimes in the 80s or in the low 90s, depending on the room temperature. So it's not much. Been pretty hot out here. So I'm very well pleased with the what I'm looking at is durability. Down the road, is this thing still going to keep working? Can I beat it? Can I max it? What can I do to this, you know, to destroy it, right? That's what I've really been doing. I had 6 FETs, I had 9 FETs, I have 12 FETs now. And these arrestor coils have really made a huge impact on heat issues. So for those of you who are having heat issues with a high powered release of you know, energy through a Mosfet, there are different ways to do it. One way to control that heat, of course, is to limit the incoming current, but also limit the surge or the arcs And remember that these coils do not throw away the energy, they store the energy, and they sort of dam up on the ingoing and put a little pressure going in, and or regulated a stream of flow going in, which is your emitter, and then coming out is your collector, and it's sort of the tiny minute amount of induction sort of dams it up going in and dams it up going out. So there's a pressure balancing on the in and the outside of that switch, and energy can be stored in these coils, and it can be evened out, and it really does work good. It really works great in saving your MOSFETs, and you still get the job done. You're going to have heat dissipation. By the way, this is 45 amp wire that I just got out of like what stoves and great big electrical stoves have. They need 50 amp breakers and 45, 50 amp wire. These are heavy braided copper wires coiled up on PVC. That's high temperature PVC with Gorilla Glue, holding them on there for a while, and they just stuck onto that tube. And then I stick them on a post. There's no cores to these other than plastic, and they're sitting on a plastic peg. I just sort of sit them on there. You'll see this little peg right here where they're screwed in, and there's a peg sticking up, and I just set that coil right on that peg and then wire them up. And you might be able to see in there a little, because I got a lot of work done here on this thing, and I can't really open the box while it's running like this. But you can see I got those bolts. The white back there is the collector, and there's 6 on that. And then there's 6 on this other one bolt, where these bolts come together, and they go to these 2 coils, and the same thing over there. So like I say, I wanted to do an update, and I'm very well pleased. I just got my new meter in the mail, another one, this one, and the amp meter. And I kind of been going working blind, because I just been going by these. I had a lower voltage meter than this, but when I was charging 24 volts today and this week, or last week even, and this week, before I got the meter, you know, I couldn't really tell where I was at when I was adjusting the circuit. So that makes a big difference. Now watch this. I'll cut this circuit way down. I'm going to go down here on the dials where the timer is, and I'm going to adjust that down to where it's hardly fluctuating, right? I'm only going between 15 and 20 volts there. Can you see that? But my amps are still the same. See that? 25 amps. But my battery runs way up fast. It goes up a lot faster, and your amp draw down here increases too. I don't know if you can see that. It will stabilize at a higher level through your resistance. There's not much fluctuation there, because I have my resistor just right. Now if I want to up it, I can take this other gator clamp here, and I can go over here, you know, to it and fool with that. You can see their amp fluctuations go way up. See that? And I can let off on the gator. See? And I'll put it back on. I can do anything I want with this circuit. It goes up. Now it's up to like 20, over 20, like 23 or 4. Or I can let it off. See? I can't hurt this circuit. That's what I'm saying. With those coils and those 12 MOSFETs, I can do anything I want to this. It'd be like turning on the supply wide open at 100 volts at 10 amps, which I can do, or higher. And those 12 MOSFETs can handle that without damaging damaging it in any way. They won't get overly hot. And that's what I wanted. Now from there I can change my circuitry where I have more control. Can do different things with it. But I'm going to button this up and keep using it and go to my means of charging the caps. This circuit here works. You know, I don't know if you remember seeing this box here down there. It's got a variac in the top. It's very dark in here. Let me turn around so you can see it again. No, I'll flip my light on around if I can turn around. I'm kind of cramped in here, getting kind of bound in. There it is. Oops, I'm sorry. Let me back this up a little. You can see the variac with the cords and the amp meter down there. That feeds this resistor right back here. I don't know if you can see that very well. It's a dryer coil out of a dryer, and it feeds those caps. So it would be better if I had another way of feeding those caps, like with generator mode, and those energizers that John Bedini has taught me to build. So I'm gonna get those working too. I got the box right over here behind me. I've got a video showing you that too. But I wanted to perfect the heat issues with the coils. See the 4 coils? That's what this video is about. Those of you who want to solve some of your heat issues, if you have some high-powered caps running, or energy levels you're running, that will help a great deal. Okay, for now that's it. And I would have liked to have shown you the whole wall moving, but I don't have the 24-volt system hooked up right now. But I will show you. It's really awesome. The whole wall, and with all those cables down there on those big cables that sweep down from the wall and go down like that, the whole thing shakes when you're pulsing a 24-volt battery. And you can really feel the clicking in here, which that's where your damage comes, I believe, with some of your Mosfets. When you're sending huge amp surges with high voltage, it's really important to have different ways to control the heat issues, and that's just one of them right there. Okay, talk to you again.